Yeah, about to do some more geometry today. I got a question back here behind me. This is a standardized test type of question. It's extremely simple. I think the only thing that messes students up or test takers is that it has a lot of words in it. So we're going to kind of talk about how you're supposed to read that question and then how you can get straight to the answer. It's a super simple problem, but don't let a question that is long deter you from getting the correct result. All right, so this question says, in the triangle DAC below segment AC is perpendicular to segment CD. Points A, B, and C are collinear, and segment DB bisects angle ADC. If the measure of angle BAD is 30 degrees, what is the measure of angle ABD? And there's the diagram right there. A lot of words, there's a diagram. Remember the first rule: when you have a problem that has this much wording, a lot of wording, find the question first. So the main thing you want to focus on here is you're trying to figure out what is the measurement of angle ABD. That's number one. So when we try to find the measure of ABD, there's ABD. So like if you were to focus on that, what we're talking about is that angle right there. That's what we're trying to figure out. Basically, that's where your question mark is, all right? Once you kind of get that main part taken care of, then you want to go back and then kind of backtrack through it. Another important thing that they say is that segment DB bisects ADC, all right? So there's angle ADC. When you bisect an angle, basically that means you split this one in half. So whatever this says, this should be the same measurement, all right? They're split into two equal parts. So I'm just taking my time explaining like the bits and pieces of the problem and how I'm looking at the diagram as I read the description. Once we kind of get that all together, then I'll show you exactly how I approach that problem, start to finish, without me explaining it. I just want to explain it on the front end first. We also have some information right here that's useful. BAD is 30 degrees. BAD, see that? BAD is 30 degrees, so that's 30 degrees right there. All right, so if AC is perpendicular to CD, there go AC across the bottom, there go DC that's up and down. When they intersect, when they meet right there at that corner, they form a 90-degree angle. Remember, 90-degree angles are something that we should all be familiar with. They make a L shape. So anytime you see that L shape, you know you have a 90-degree angle. They're everywhere. That right there, perpendicular. If I look up here, we got perpendicular. If I look out the window, we got perpendicular lines there. So perpendicular lines are everywhere and they're all around you. So the symbol we use for perpendicular is an upside down T. See that? The upside down T means perpendicular. And when things are perpendicular, they create a 90-degree angle. We use that symbol for 90 degrees. So 90 degrees, that's the symbol that we use. And since we know that this is perpendicular, I can put that there, or I can put 90 degrees there, but I like to use my symbol. So if I ignore the fact that we have a bisecting segment and I just look at the whole triangle, I have 30 degrees right here for angle A. I have 90 degrees here for angle C, which should leave me with 60 degrees for angle D. Remember, the total should always be 180. So if that's the case, I have 30, that should be 60, and that should be 90. All right, so I'm about to put it all together. Now, here we go. We know that that is 30 degrees from earlier. So I got my 30 degrees here. We also know that this is 60 degrees, but it has been bisected. So I'm not going to write 60. I'm going to split that into 30 and 30 equally. All right. And this is the one that we have the question mark in down there. We don't know. Let me make sure that looks like a question mark. So that's my question mark. I don't know what that degree measurement is, but I don't need this part of the triangle anymore to figure it out. So I ignore that and I look at this one triangle. And then literally, to figure out what that is, all I really need to do is take the 180. Remember, the total is always 180 inside of a triangle when you add up all three angles. And I subtract 30 and 30, so that basically means I subtract 60 to get me 120. This angle is worth 120 degrees. That's what the question mark was. So if you don't know your definitions and you see a problem like this behind me and you see all those words, normally your first assumption is, okay, this is going to be a hard problem or it's going to take me a long time to get it. But if you understand what your definitions are, like what does it mean when something is perpendicular? What does it mean when an angle is bisected? If you know your facts, like if I add all three interior angles up on my triangle, my total is 180. If you know those definitions, this is really just a fancy way of saying subtract two numbers and get your answer. So this problem can literally be solved by anybody. I don't care how old you are. If you know how to subtract, you can solve this problem. The question is, do you know how to reason so that you can solve the problem? So the reasoning is what's going to lead you down the right path, because we're not going to set the problem up for you. We're not going to give you a problem and say, what is 180 minus 160? But what we will do is give you a triangle with two known measurements, and then you have to understand from that, I need to subtract to get 120. So the main thing is with geometry, reasoning skills are important. Reasoning skills are very important. So this one is a representation of what we kind of just did. These two angles right here are equal because this one has been bisected. I don't know if you can see the numbers, but that's 37.1, 37.41, just like that's 37.41. We have our right angle that sits right there in the corner, and we have our other angle that sits way out here on the end. So like if you were to add this one up right here in green, plus this 90, plus what both of these say, you'll get 180 degrees, right? Now, if I were to get rid of that and not focus on that one and just look at this triangle here, we call that one an obtuse triangle. If I were to take this blue number, take this one number right here, and that one number right there, I'll also get 180 degrees. So this problem here, the only tricky thing about it is that they compounded the triangle. So there was a triangle inside of a triangle. So it's so many ways you can look at this. So when I see a problem like this, I see one big triangle, and then I see two smaller triangles. So technically, if you dissect this, it's three ways you can look at this problem. But the thing is, do you know which ones are important to get you to this angle here? So I like to kind of show these because with this software, you can see how all the numbers add up even when I move this around. So even when I move this around, you'll be able to recalculate everything. And you'll see that all the rules hold true no matter what. That's one of the good things about understanding these rules and theorems. They've been proven way before I got here, and they do work, and they always work.